Welcome to the Code Navigators. This is the show where we try to chart a clear path through the, let's be honest, sometimes pretty dense ICC code books.
Yeah, definitely done sometimes.
Our whole goal here is to go chapter by chapter. We break down the key stuff, trying to pull out the information you really need.
Whether you're, prepping for an ICC exam or just need to understand a specific part of the code for a project, we want to help you get that solid understanding faster.
We use AI to help structure things, but, and this is important, everything is checked, edited, and overseen by a real human code professional. Me, in fact.
Right. So you get accuracy and hopefully clarity.
Okay, before we jump into today's chapter, we absolutely have to cover the legal disclaimer. It's really important.
It is. Please remember, everything we talk about here, it's strictly for educational purposes. Think of it as like a study guide or an overview.
It is definitely not professional advice, not legal advice either. You can't use this as the final word for your specific project.
No, absolutely not. You always need to consult the official current code. For today, that's the 2021 IBC, the International Building Code. And for specific questions, talk to a qualified pro, an architect, engineer, code official, whoever is appropriate for your situation.
We're just discussing the concepts and structure here, stuff that's in the public domain, nothing copyrighted.
Okay, disclaimer done.
Right. So today's focus, Chapter 6 of the 2021 IBC. The title is Types of Construction.
And this chapter is, well, it's foundational. Doesn't matter if you're building a tiny house or a skyscraper, you have to deal with Chapter 6. It really sets the stage for almost everything else related to fire and structure.
It defines the basic DNA of the building, right? It dictates what it can be made of, how much fire resistance it needs.
Exactly. And that ties directly into Chapter 5, height and area limits, and Chapter 7, the fire resistance rated construction details. Our mission today is to help you get comfortable with how buildings get classified, what those classifications mean for fire ratings, and how the code handles materials, especially combustibles.
And we'll definitely spend some time on Type 4, the mass timber stuff. That's a big area and crucial for exams, too.
Oh, yeah. Very high yield for exams. Okay, let's start at the beginning. Sections 601 and 602, the general scope.
Section 601.1 is pretty straightforward. It just says this chapter sets up the 5 basic types of construction. Type 1, Type 2, Type 3, Type 4, and Type 5. Every building gets slotted into one of these.
And that classification immediately does 2 big things. First, it tells you about the materials. Can the main parts, the frame, floors, walls, roof, be combustible, like wood, or do they have to be non-combustible, like steel or concrete?
Okay, material combustibility. That's number 1.
And number 2 is the fire resistance rating. How long do those elements need to hold up in a fire? Is it 0 hours, meaning basically unprotected, or is it 1, 2, or even 3 hours?
3 hours is serious protection.
It is. That's typically for your most robust buildings, like Type 1, then it steps down. Type 5, at the other end, often has minimal or 0 ratings for a lot of the interior structure. It's a scale, basically, based on perceived risk.
Now, Section 602.1 has this interesting point about minimum requirements. It says a building doesn't have to be built to a higher standard than what's needed for its occupancy or its size. Why spell that out?
Well, it's really about efficiency and practicality. Imagine you have maybe a small retail space.
Yeah.
Based on its size and use, it only needs to be Type 5B construction according to Chapter 5.
Okay.
But maybe the owner could afford to build it as Type 3B. Section 602.1 clarifies that the code isn't forcing you to upgrade. If 5B meets all the requirements from occupancy, height, area, fire separation, all that, then 5B is perfectly fine. You don't get penalized for not choosing the more robust, more expensive option if it's not actually required.
That makes sense. Avoids unnecessary costs. Okay, let's quickly walk through the 5 types again, just the basics with 602.2 through 602.5.
Sure. So types 1 and 2 are your non-combustible categories. Think steel, concrete, masonry for the main structural element.
Non-combustible. Got it.
The main difference between 1 and 2 usually comes down to the required fire resistance ratings. Type 1 generally demands higher ratings, more protection than Type 2.
Then Type 3. This is where it gets mixed, right?
Yeah, Type 3 is a bit of a hybrid. The key thing is the exterior walls must be non-combustible. That's often driven by proximity to property lines, but inside. The floors, the roof, the interior frame, those can be combustible, like wood, as long as they meet the required fire rating for Type 3A or 3B.
Okay. Non-combustible shell, potentially combustible core. What about Type 4?
Type 4 is the big one for timber. Historically, it was just heavy timber HT, big solid wood beams and columns. Now it's expanded to explicitly include mass timber.
Like CLT, cross-laminated timber.
Exactly. CLT, glulam beams, SCL, structural composite lumber. Again, the exterior walls have to be non-combustible. But the interior structure is built with these massive wood elements designed to char predictably in a fire, providing inherent fire resistance.
And finally, type 5, the most common one.
Probably, yeah. Especially for houses and smaller buildings. In Type 5, pretty much everything structure, exterior walls, interior walls can be made of any material the code allows. And very often that means light wood framing.
And type 5B, the lower subtype, often has 0 fire rating requirements for interior stuff.
Correct. A lot of the interior structure in 5B can be unprotected. Fire safety relies more on things like smoke alarms and separation distances.
Okay, so that's the basic hierarchy. Type 1 down to type 5. That framework is essential.
Absolutely. It sets the stage for the details.
Which brings us squarely to Table 601. If Chapter 6 is the foundation, this table is, well, it's the blueprint for the fire ratings. You can't really do anything without understanding this table.
You really can't. Table 601, fire resistance rating requirements for building elements. Hours. It looks like a simple grid, but man, the details matter. It's critical for design and definitely critical for any ICC exam.
Let's break down how it's organized. Down the side, the rows.
Yeah.
Those are the building parts that need rating, right?
Yep. You've got the primary structural frame, that's your columns, girders, trusses, the main load-bearing stuff. Then bearing walls, both interior and exterior. Non-bearing walls, again, interior and exterior. And finally, floor construction and roof construction.
Okay, those are the elements. And then across the top, the columns. That's our 5 construction types.
Right. Type 1, 2, 3, 4, and 5. But importantly, most are broken down further into subtypes.
Ah, yes. The A's and B's. Types 1, 2, 3, and 5 have A and B. Type 2 also has a C. And Type 4 has HT for heavy timber. And then the newer subtypes for mass timber, sometimes labeled C.
Those A and B designations are probably the most fundamental distinction within the types. Huge impact on cost and complexity.
So what's the core difference? A versus B.
Think of it like this. A generally means protected, and B generally means unprotected.
Protected versus unprotected.
Okay. So if you're building Type 3A, for example, the A means the structural elements, the frame, the floors they need to be protected to achieve the required fire rating. That usually means wrapping them in something like gypsum board or spray-applied fireproofing.
Adding layers for fire resistance.
Exactly. But if you're building Type 3B, the B means many of those same interior elements are considered unprotected. They can often be left exposed, and the required fire rating might be lower, maybe even 0 hours for some interior parts.
So going from, say, Type 2A down to Type 2B could save a ton of money, right?
Yeah.
No need to fireproof all the steel beams and columns.
A massive difference. That A designation means materials, labor, time, all spent on applying fire protection. The B often eliminates a huge chunk of that cost for the interior structure. That single letter difference is a major budget driver.
And Type 2C is even less restrictive.
Yeah, Type 2C is sort of the lowest tier of Type 2. It often allows 0-hour ratings for even more elements, sometimes including exterior non-bearing walls, where 2A and 2B might still require an hour.
Let's look at the extremes in the table. Type 1A, that's the top tier. What kind of ratings are we talking about there?
Type 1A is built like a tank, usually reserved for very tall buildings, critical facilities. The primary structural frame, that needs a 3-hour rating.
3 hours, wow.
Exterior bearing walls, 3 hours. Interior bearing walls supporting multiple floors, also 3 hours. Achieving 3 hours requires really substantial construction assemblies. It's all about ensuring structural integrity for a long time, giving people plenty of time to get out and firefighters time to work.
Okay, now contrast that with the bottom end, Type 5B.
Type 5B is almost the complete opposite for the interior, the primary structural frame. Usually 0 hours required. Interior bearing walls, 0 hours. Interior non-bearing walls, 0 hours.
0, 0, 0.
Pretty much. That's why your typical wood-framed house fits here. The code relies more on things like smoke detection and escape routes rather than inherent structural fire resistance for the inside. Exterior walls might still need a rating depending on how close they are to the property line, though.
Right, that's an important point. Let's dig into bearing walls a bit more. You mentioned interior versus exterior. Why the difference? Let's take Type 3A again. Interior bearing walls supporting more than one floor need 2 hours. But exterior bearing walls need 2 hours regardless. Why?
It's about the source of the potential fire. An interior bearing wall failure is bad. because it can affect multiple floors, maybe compromise escape routes. So if it supports a lot of load, it needs a higher rating, like 2 hours in 3A.
Okay, internal collapse risk.
But the exterior bearing wall faces a different threat. Fire coming from outside, a fire in a neighboring building maybe. That outside threat doesn't care how many floors the wall is supporting inside. So the exterior wall needs that 2-hour rating in 3A primarily to protect the inside of the building from an external fire source.
Okay. Interior walls are about containing an internal fire and load. Exterior walls are about keeping external fire out.
You got it. And that brings us back to the primary structural frame definition in Chapter 2. That's the skeleton, columns, beams, trusses, anything critical for stability. The ratings vary wildly across the types. 3 hours for 1A, often 1 or 2 hours for Type 4 mass timber, depending on the specifics, down to 0 hours for 5B. It reflects the code's assessment of risk based on size, height, and combustibility.
We absolutely have to talk about the footnotes in Table 601. Ignoring notes A through G is a classic mistake.
Oh, definitely. The numbers in the table are just the start. The notes modify those requirements significantly. Let's look at D, E, and F. They're really important.
Okay, note D. This one seems key for Type 4 mass timber.
It is. Note provides a big exception. It says you don't need the listed fire resistance rating for the primary frame and roof structure in certain Type 4 buildings. The conditions are, the building can't be more than 2 stories or 60 feet high, and you have to meet some other criteria, usually about protecting the exterior.
2 stories or 60 feet. So if I build a 3-story Type 4 building,
Then you lose that exception from Note D. You'd likely have to protect the frame according to the main table values, maybe 1 or 2 hours, depending on the Type 4 subtype you're using, like 4B, 4C, or 4HD. That height limit is a critical trigger point.
okay, what about note E?
Note E points you elsewhere. It often relates to exterior non-load-bearing walls and sends you over to Chapter 7, specifically Section 705, which deals with exterior walls based on fire separation distance, how close they are to the lot line or other buildings.
So Table 601 might say 0 hours for an exterior non-bearing wall in Type 2B.
Right, but if that wall is, say, only 3 feet from the property line, Section 705 is going to override Table 601 and probably demand a 1-hour rating, maybe even 2 hours, regardless of the construction type.
That's a perfect example of how different code sections interact. You can't just look at one table in isolation.
Never. And then Note A gives us a specific rule for Type 4 heavy timber HT bearing walls. It says if those big timber walls support more than 2 floors, or a floor and a roof, they need at least a 1-hour rating.
Even if the main table might otherwise allow 0 hours for a Type 4 HT bearing wall supporting less.
Exactly. Supporting more stories means more load, more potential consequence if it fails. So the code adds that specific 1-hour minimum requirement for those heavily loaded, heavy timber walls.
Wow, okay. The level of detail is intense. It's not just wood or steel, it's how it's used, where it's located.
Precisely. Function, location, load. It all plays into the required protection.
All right, we've covered the basics in the core table. Let's pivot now and focus entirely on Type 4 construction, Section 602.4. This feels like the area with the most change recently, with mass timber really taking off.
It absolutely is. Type 4 is a fascinating blend of old and new. It takes the historical concept of heavy timber's inherent fire resistance and applies it to modern engineered wood products. The whole philosophy is different from Type 1 or 2.
So, because it's combustible, right?
It is combustible, but it's predictably combustible. The idea is that these massive timber elements, CLT panels, big glulam beams, are so thick that when exposed to fire, the outside layer chars. That char layer acts as insulation, protecting the inner core of the wood, which keeps carrying the load for the required time.
So it performs like a rated assembly, even though it's burning slowly.
That's the concept. Section 602.4 lays out the ground rules. Exterior walls still need to be non-combustible, but the interior structure must be either traditional heavy timber, meeting minimum sizes, or mass timber elements like CLT, SCL, or glulam. And then the following sections, 602.4.1 through 4.5, get into the nitty-gritty details.
Let's start with 602.4.1, the materials themselves. What are the key requirements?
Well, it defines what qualifies as mass timber, the CLT, SCL, glulam we mentioned. It also covers fire-retardant treated wood, FRT wood, saying if it's used, it needs to be pressure-treated and properly identified. For CLT used in exterior walls, it often specifies a minimum thickness, like maybe 4 inches, and might require an inherent 1-hour rating.
And for the traditional heavy timber, the HT classification, what kind of sizes are we talking about to qualify?
We're talking substantial dimensions, defined back in Chapter 23, Section 2304.11 usually. Think columns that are at least 8 by 8 inches nominal, or beams maybe 6 by 10 or 8 by 8 minimum, depending on whether they support floors or roofs. It's that sheer bulk that allows the charring mechanism to work effectively.
Okay, big wood. Now, protection. Section 602.4.2 talks about encapsulation. This is crucial for whether you can actually see the wood, right? Starting with 602.4.2.1, the exterior covering.
Right. Even though the mass timber might be part of the exterior wall structure, it usually needs to be protected on the outside by a non-combustible covering. And this isn't just any covering, it has to perform.
Perform how?
It often needs to contribute a certain amount of fire resistance itself, say 20 minutes. But more technically, the code limits the total heat release from that covering during a fire test, often to less than 150 megajoules per square meter.
150 mj per raw fire. That sounds specific. It's limiting how much fuel the covering adds to the fire.
Exactly. And it also typically needs a low flame spread index, 25 or less, usually tested to ASTM E84 or UL 723. That measures how quickly fire spreads across the surface. Low heat release, low flame spread. It ensures the covering doesn't make the fire worse while it protects the timber behind it.
Okay, that's the outside. What about inside? Section 602.4.2.2, interior protection.
For higher Type 4 ratings, the interior surfaces often need protection too, usually non-combustible materials like Type X gypsum board. The amount of protection depends on the rating needed. For example, walls might need protection contributing 40 minutes, while floors might need 80 minutes.
Wait, 80 minutes of gypsum board over a massive timber floor? That seems to defeat the purpose of using mass timber aesthetically.
It can, yeah. If you fully encapsulate everything, you lose that visual appeal, which is why Section 602.4.2.3, the exposed mass timber exceptions, is probably the most important part of Type 4 for designers.
This is where you get permission to leave some wood exposed.
Exactly, but it's not a free-for-all. The code allows limited amounts of the mass timber structure to remain unprotected, but under very strict controls.
And the main control is this equation 6.1 for mixed unprotected areas. What's that trying to achieve?
Equation 6.1 is basically a balancing act. It recognizes you might want to expose some ceiling and some wall area. The formula ensures that the combined percentage of exposed area relative to the maximum allowed for each doesn't go over a safe limit, effectively 100% of the total allowance.
Okay, let's just state the formula and define the parts. No calculations needed.
Sure. The formula is UAAC plus UWUAC needs to be less than or equal to 1.
Okay.
Where UA is the actual unprotected ceiling area you have. UAC is the maximum allowable unprotected ceiling area, which you find elsewhere based on building height, sprinklers, etc. UW is your actual unprotected wall and column area. And UWC is the maximum allowable unprotected wall area. So it's the ratio of actual exposed ceiling plus the ratio of actual exposed wall, and the sum can't exceed 1.
Got it. It's a proportion check. If you use up your wall allowance, you have less ceiling allowance left, and vice versa.
Precisely. It forces trade-offs to limit the total fuel load. But there's another rule, too, a spatial one.
The separation distance.
Yeah. Unprotected areas of mass timber generally need to be separated from other unprotected areas, on walls or ceilings, by at least 15 feet measured horizontally along the floor.
15 feet. Why that distance?
It's about preventing fire spread. That 15-foot break, presumably covered with non-combustible material like drywall, acts as a fire block. It makes it harder for flames to jump directly from one large exposed timber surface to another, keeping the fire more localized.
Makes sense. Limits rapid spread. Are there also hard percentage caps on exposed areas?
Yes. Even with the formula in separation, there are overall limits. For floors and roofs, the total unprotected mass timber area usually can't exceed 20% of the floor area within a specific fire area or dwelling unit.
Only 20% for ceilings floors.
Right. For walls and columns, the limit is typically higher, often up to 40% of the floor area.
Okay, 40% for vertical element.
And then there's often a combined limit, too. The total area of all exposed mass timber surfaces, walls, columns, ceilings, floors combined, might also be capped at 40% of the floor area. So you can't max out both the walls and the ceilings. You have to choose where to feature the exposed wood.
It's a tightly controlled allowance. Let's quickly touch on concealed spaces in Type 4, Sections 602.4.2.4 and 602.4.2.6. What about voids behind walls or above ceilings?
Since the structure itself is combustible, concealed spaces are a big concern. The general rule is they have to contain only non-combustible materials.
Unless
two things are true. The space is fully sprinklered according to the high standard of 903.3.1.1, and the space is completely filled with non-combustible insulation. So you either eliminate the void with insulation or you protect it heavily with sprinklers.
very strict.
It is. And even within interior walls that already have a 1-hour rating, if they conceal mass timber, they might need sprinklers inside the cavity or an additional layer of non-combustible protection, like 40 minutes worth added inside the void. Managing fire spread in hidden spaces is paramount in Type 4.
This focus on managing combustibility in Type 4 leads perfectly into Section 603, because this section deals with combustible materials allowed in Types 1 and 2, the supposedly non-combustible types.
Right. This throws people sometimes. If Type 1 is non-combustible, how can you have wood trim or plastic pipes? Section 603 is the code acknowledging reality. A truly 100% non-combustible building isn't practical, so it provides a list of specific, limited exceptions where combustible materials are permitted.
It's recognizing that things like finishes, insulation, and utilities are necessary, and if controlled, they don't compromise the overall safety goal of Type 1 or 2.
Exactly. The core structure remains non-combustible and provides the required fire rating. Section 603 just allows certain other materials under strict conditions. Let's look at fire retardant treated wood first. Section 603.1.1.
FRT wood. That's wood treated to resist burning. Where can that be used in Type 1 or 2?
It's allowed for some non-load-bearing elements, like non-bearing partitions inside, or roof construction elements, like blocking or sheathing, where a fire rating isn't required for the roof itself. Also, certain non-bearing exterior walls where no rating is needed.
But there are big restrictions for Type 1A and 1B, the highest types.
Very big restrictions. You generally cannot use FRT wood for structural elements in Type 1A or 1B. However, there are a couple of narrow exceptions.
Okay.
Exception 1, it might be allowed in the structure if it's located near the top of the building, specifically 25 feet or less below the roof. The idea is the risk is lower up there. Exception 2, if the FRT wood is covered by other materials, even non-FRT wood, within an assembly that isn't required to be rated anyway, it might be okay. But generally FRT wood in the main frame of a Type 1A building, no.
Good to know.
Okay.
Now, the main list in 603.1, 27 points, allowing combustible stuff. Let's set some highlights. Point 1 seems huge. Foam plastics.
Yeah, foam plastic insulation. Highly combustible stuff. It's only allowed if it complies fully with Chapter 26.
And Chapter 26 has incredibly strict rules, right?
Yeah.
Thermal barriers, special fire tests like NFPA 285 for walls.
Exactly. Section 603 doesn't just say foam is okay. It says foam is okay if you meet all the rigorous protection requirements in Chapter 26. Usually that means covering it completely with drywall or another approved barrier. The allowance is very conditional.
Okay. Point 5, finish flooring and coverings. That seems necessary. Carpet, wood floors.
Right. These are permitted because they're surface finishes. They don't typically affect the structural fire resistance, which comes from the non-combustible slab underneath. They still have to meet flame spread requirements from Chapter 8, though.
What about things like doors, windows, trim? Point 6, 7, 8.
Also allowed. You can have wood doors, wood window frames, wood baseboards in a Type 1 building. But again, there are limits. For trim, for example, the total amount of wood trim is usually limited to 10% of the wall and ceiling area in a room. You can't just cover the walls in wood paneling under this exception.
Quantity control is key. Point 9 mentions wood furring strips, but only if they're spaced 4 feet apart or less.
Yeah, furring strips are used to attach finishes or level surfaces. Limiting the spacing to 4 feet limits the amount of wood and creates smaller compartments. If the space between them is filled with non-combustible insulation, it's even better. It's a practical allowance for construction.
Point 11 sounds like it helps tenants. Temporary partitions in stores or offices, single tenant, under 30 feet long.
Right. Allows for quick, flexible fit-outs using potentially combustible partitions, but the key limitations are the length, 30 feet max, and the function they can't be used to create required corridors serving a significant number of people. If it becomes part of the main exit path, it needs to meet higher standards.
Function matters again. Point 13 allows combustible exterior items like wall coverings, balconies. This is why we see wood siding on some steel buildings.
Yes, potentially. Provided those items comply with other rules, especially in Chapter 7 regarding fire separation distance and Chapter 14 for exterior walls generally. If the wall itself meets its required rating and the combustible add-on doesn't compromise that or create an undue hazard based on proximity to the lot line, it can be allowed.
Okay, and we absolutely need to cover utilities. Points 26, 27, and the subsections 603.1.1 through 1.3 on pipes and wires.
You can't have a modern building without electricity and plumbing, and those often involve combustible plastics. Section 603 permits things like plastic electrical boxes, wire insulation, and combustible piping.
But with conditions, I assume.
Big conditions. For combustible piping like PVC drain lines or CPVC sprinkler pipes, Section 603.1.2 allows them only if they comply with the specific limitations in the mechanical code and plumbing code.
So the IBC says, yes, you can use the plastic pipe, but the other codes say, here's how you must install it safely.
Exactly, especially focusing on penetrations. If that plastic pipe goes through a 2-hour rated concrete floor slab, the IMC or IPC will require a listed fire stop assembly around that pipe that maintains the 2-hour rating of the floor. The permission comes from IBC 603. The protection method comes from the other codes.
Okay, one more interesting one. Point 20 allows adding heavy timber members to a Type 1 or 2 structural frame.
Yeah, this is a cool one for aesthetics. Say you have a Type 2A steel frame building, but the architect wants the look of exposed heavy timber roof trusses. Point 20 allows you to add those timber trusses, but the specific timber elements have to be designed and built to meet the requirements for Type 4 heavy timber construction, often referencing Note C to Table 601.
So you're embedding a Type 4 element within a Type 1 or 2 building, and that element has to meet the higher standard.
Essentially, yes. It allows architectural flexibility while ensuring that the introduced combustible element has the inherent fire resistance associated with heavy timber. It's a performance-based allowance.
Looking at Section 603 overall, the big picture seems to be that non-combustible construction isn't absolute. It's about ensuring the primary structure survives, while allowing necessary limited amounts of combustible materials when they're properly controlled to protect it.
That's a great summary. It's a balance between the ideal of non-combustibility and the reality of modern construction materials and methods. The code manages the risk through limitation and protection.
Okay, as we wrap up this look at IBC Chapter 6, let's try to boil down the absolute key takeaways for listeners, whether they're studying or designing.
Number one, absolutely. Classification is everything. Deciding if a building is type 1, 2, 3, 4, or 5 is the first most fundamental step. It drives material choices, size limits, everything.
Right. Second, Table 601 is your essential map for fire ratings. You have to know how to read it, understand the A protected versus B unprotected difference, and crucially, pay attention to those footnotes, D, E, F especially, which modify the base requirements.
Third, type 4 mass timber is complex. It's not just about using big wood. It's about meeting specific performance criteria for protection, like heat release limits, and carefully managing any exposed timber using equation 6.1 and the 15-foot separation rule. The details there are critical.
And fourth, Section 603 shows the code's practical side. Combustible materials are allowed in Type 1 and 2, but only in specific limited ways, often relying on protection requirements detailed in other chapters like Chapter 26 for foam or the mechanical plumbing codes for pipes.
Mastering Chapter 6 really means understanding the language the code uses to balance structural integrity, fire safety, material properties, and cost. Every rating, every exception reflects a risk assessment.
It does make you wonder, as material science keeps evolving, especially with engineered wood and composites, will we see the code rely less on these rigid Type 12 non-combustible definitions in the future? Could it shift more towards performance-based calculations for everything, kind of like how Type 4 is handled now?
That's definitely something people in the industry are thinking about. A provocative thought indeed. For now, though, mastering the current Chapter 6 and Table 601 is essential work for anyone involved with building design or regulation.
Agreed. And if you found this walkthrough useful for your studies or your work, please consider supporting the show. There's a link to our Patreon page in the description. Your support helps us keep producing this content.
We appreciate you joining us to navigate the codes.
Until next time, stay safe and build smart.